Okay, so solving for x here, what is 10 squared? 100. What's 9 squared?
81.
81. Okay, equals x squared. What's 100 plus 81?
181.
So 181 equals x squared. Now, I want to know what x equals. I don't want to know what x squared equals. So how do I get rid of that squared? Square root, right? The square and square root are inverse operations. They cancel each other out, basically. I don't like that phrase, but anyways, whatever. They're inverse operations. So to get rid of that square, I take the square root. If I square root that side, I've got to square root this side. Over on the right-hand side, that just goes to x. And what's the square root of 181?
13.
Okay, so just as a decimal, 13.45 is what we get. Okay? All right, number 2. 5 squared is 25. X squared, 11 squared is 121. Okay, we're going to subtract 25 from both sides. This zeroes out. This leaves x squared equals 96. And to find out what x is, we just take the square root. And what's the square root of 96? It's like 9.797979. So we'll just round it to 9.8. Okay, then on number 3, 12 squared is 144. 15 squared is 225. Subtract 144. This zeroes out. We get x squared equals 81. And so x equals what? 9. X equals 9. X equals 9. Okay, so today we're focusing in now on Pythagorean Theorem. Pythagorean Theorem. So again, this is something you learned in 8th grade. I don't know how much of this you did in Algebra 1, but you should have seen some of it. What does the Pythagorean Theorem say?
A squared plus b squared equals c squared.
Okay, a squared plus b squared equals c squared. A squared plus b squared equals c squared. Now, obviously on a triangle there's 3 sides, and that's what the A, B, and C represent, is the length of those 3 sides. Now, of those 3, A, B, and C, the most important one to get right is the C. So on a right triangle, what is the C talking about? Okay, what's the way that we know what it is? Okay, the C is the longest side of the right triangle. It's the longest side. And what's the special name for that longest side on the right triangle?
Hypotenuse.
Good. It is a hypotenuse. Hypotenuse. On this triangle right here, I'm going to label where the right angle is. Okay. And which side is the C?
Isn't it the one across from me?
Is this one the C?
No, the one
Is this one the
across from
C?
me.
This one is the C. That's the longest side. Okay. So that's the C. That's the hypotenuse of the triangle. Okay, and then from there, it doesn't matter where I put the A and the B. As long as I get the C right, we're good. Bless you. Okay. Next one, here's the right angle. Okay, here's the C, and then again, the A and the B don't matter. Okay, a trick that I've seen people talk about is to know where the C is the hypotenuse. The right angle is always like an arrow pointing towards the hypotenuse. Okay? All right, so on this one, here's the C, here's the A and the B, and then on this one, here's the right angle, here's the C, the A, and the B. All right. On this square right here, which side is the C?
The 1 over 2.
Okay, so here's the C. And then, like, this would be the A, this would be the B. And again, it doesn't matter. As long as I got C there, the B and the A could be switched, and that wouldn't matter. So here's what I want you to do. And just freehand this. It doesn't have to be perfect. But what I want you to do is from this side is I want you to draw a square. Ooh, that's terrible. Yeah, that's terrible.
So it should be half of the square because
Something like that. Okay. Now I want you to draw a square off of side A. And then do the same thing with side C.
Oh, you took a bigger triangle. I mean, that's how you can find out where the C is.
Okay, so something like that. Again, it don't have to be perfect. I just want you to see that. Okay, so next thing I want you to do is on this next triangle here. All right, on this triangle right here, what I want you to do with your rulers, I want you to measure all three sides in centimeters. Measure all three sides in centimeters.
Which on the bottom one?
Yes, this one down at the kind of bottom middle by itself there. Measure all three sides in centimeters.
But once it's actually safe, dude. Yeah, you good? Yes, Jocelyn, really.
Okay, so how long is this side down here? 4. Okay, how long is this side over here? Is 3 centimeters. And then this one right here is 5 centimeters. Okay. So here's my right angle. Okay, which one of those is the C side? The 5. This is the C. And then I'm going to say that this one right here is the A, and that this one right here is the B. Okay, now on the back of your do now is grid, okay? And these are close to being exactly 1 centimeter by 1 centimeter. They're off by a tiny, tiny little bit, but they're very, very close. Okay, so what I want you to do is for this side right here, I want you to cut out of that grid, I want you to cut a 3 by 3 square. Okay? So with your scissors, you're going to cut out a 3 by 3 square here. Okay, so for this side, you're going to cut out a 3 by 3 square. Now we're going to cut out one for this side and this side. So what do you think these need to be?
5 by 5 and 4 by 4.
A 4 by 4 and a 5 by 5. Yes. So you're going to have a 3 by 3, a 4 by 4, and a 5 by 5. Cut those out. Okay, so once you get those cut out like that, I want you to glue them in place. Okay? So glue this one right up against there like that. Glue that one right up against there like that. And this one right up there like that.
Says one that always takes the second one too.
Oh, yeah, because when there's streets. Okay, well, maybe she'll have to yeah.
So like 6 grade.
What?
Like 10 streets or so last year. Streets or so last year. Because I still live last year. He lives in the past. Exactly.
Okay, so what I'm going to do is I'm going to label these squares. All right? So this square right here is based off of which side? A. Side A. So I'm going to call this square A. So this square based off of side A. So what do you think I would call this square?
Square B.
Square B.
Square.
And then what would I call this? We'll call this square C. All right. Now, let's think about each of these squares. So for square A, okay, what is the area of this square? How many squares are inside of here? 9. Or you could think of it as it is a 3 by 3, right? What is 3 times 3?
9.
Is 9. So the area of this square is a 9 square centimeters. Area of this is 9 square centimeters. Okay, what's the area of square B?
16.
16. It's 4 by 4. 4 times 4 is 16, or if you counted all the squares, there's 16. So the area of this square is 16 square centimeters. Okay? What's the area of square C?
25.
25. It's 5 by 5. If you do 5 times 5, that gives you, keep doing that, 25 square centimeters. Okay. Now, what does the Pythagorean theorem say again? A squared plus B squared equals C squared. Okay? That is what the Pythagorean theorem says. Now, actually, we can read that in a different way. Okay? Instead of saying A squared plus B squared equals C squared, watch, this is what I'm going to do. It's going to be square A plus square B equals square C. Okay? Square A plus square B equals square C. So think about this. If you take this, the area of square A, and this, the area of square B, what is 9 plus 16? 25. Is 25. Okay? So that's what the Pythagorean theorem says. On any right triangle, if you take the number of squares from this side and the number of squares from this side, in other words, from side A and B, when you add all those squares up, it's going to be the same number of squares that you get on side C. Okay? So, in other words, here we have 9 plus 16 equals 25. Okay, so square A plus square B equals square C. Okay, so that's what we're going to be doing today is practicing with this specific idea with the Pythagorean theorem. So on the back, okay, so what I want you to do is in centimeters, I want you to measure the length here of square A. In centimeters, measure the length of square A here. What is it?
I got 3.
It's 2.9.
So 3.
Okay, so 2.9 by 2.9, right? If it's a square, same length as it is its width. Now, how do we find the area of a square?
Length times width.
Yeah, just like we did over there. Like a 3 by 3, you just do 3 times 3 to get 9. Here, it's just going to be 2.9 times 2.9. So plug that in your calculator quick. 2.9 times 2.9. Okay, 8.41. And I'm going to put it right here. That's what this is for. So the area of square A is 8.41. Okay, let's find the area of square B. Okay, so what is the width or the length of this square? Okay, about 1.5. So 1.5 by 1.5. That's what? 2.25. Now, on this next line, what I want you to do here is just to add the area of square A and square B. So if you take this number and this number, just add these two up to give you this right here.
10.66.
So I'm going to do 8.41 plus 2.25 and 10.66. All right, and then let's do the same thing. Find the area of square C. So how long is this side on C? About 3.2.
And that would give you
So 3.2 times 3.2,
10.24.
okay, is 10.24. Whoops, sorry. There we go. 10.24. And the reason these are not exactly the same is because we're definitely rounding here, all right? These are actually like falling kind of in between and stuff. But in practice, in theory, these should be exactly the same. Okay, if we were to measure more precisely, these would be way closer to being equal. Okay, let's do one more real quick. Let's do this one. So let's find the area of square A. .4. So 1.4 squared is what? 1.96. Okay, let's find the area of square B. Okay, it's 3.9. So 3.9 times 3.9. 15.21. Okay, then when I add square A and square B, what do I get? Okay, 17.17. Okay, now on C, okay, I'm gonna get real picky on this one because I want to get this closer. Okay, so if you look, it's actually a little bit more than 4.1. Okay, it's not all the way to 4.2. So we'll say, and I'm even going to go a little bit even more than that. I'm going to say 4.14. It's a little bit more than 4.1, but it's not all the way to the halfway point between 4.1 and 4.2. So I'm going to go 4.14. All right? So 4.14 is what? 17.14 if we round it. Okay, and you can see how close that gets us. And again, the reason they're not exact is because we're rounding.
But it was close enough.
Yeah, that's pretty good right there. Okay. So on your assignments, you're going to be doing the same thing on your assignment that we're doing right here, except for the last problem. On the last problem, you're going to do the same thing that we did right here. And you're going to use these little tiny squares for that. Okay? You'll be cutting these out and gluing them on the back here of this assignment page.
Joshua, do you have the alpha?